Hi Vikings, Mr. Mac here. Here's a little help with your IM1 Week 4 assignment number 1. In the first problem, you're going to be looking at percent increase and percent decrease. So if you'll remember, a tax means it's going to increase the price, and if it's something that's it's 25% off, for example, you're going to be decreasing the price. So keep that in mind. When you're figuring out the multiplier, if something was a 10% increase, for example, you're going to take the number 1 and you're going to add the decimal equivalent of that percentage. So you're going to take your percentage, you're going to change it to a decimal by moving 2 places to the left. So that'll be 1 plus 0.1, which means your multiplier is 1.1 for a 10% increase. If, on the other hand, you're going to do a decrease of 10%, then you're going to take that number 1 and you're going to subtract the decimal, which is 0.1, which is going to come out to 0.90. Okay, so that is your multiplier to figure out a 10% decrease. Hopefully that rings a bell. In problem number 2, we're going to be finding the equation of a line given 2 points. Here's an example of how to do one similar to number 2. Let's see, the points you're going to be using for your example are going to be -2 and 6 for your xy, and then the other one is going to be 4 and 3. So those are coordinates of 2 points that are on a line, and we're going to try and find the equation of a line. If you'll remember, the equation of a line is y equals mx plus b, where m is the slope and b is your y-intercept, and then your x and y are the different coordinates that we have here. All right, so to find the equation of a line, first we got to find the slope. So m is equal to the change in the y's over the change in the x's. So we can just take a look at the y coordinate here, say 6, and we can subtract it from the other y coordinate, 3. And then over the x coordinates, we're going to find that x coordinate -2, and we're going to subtract what the x coordinate is over here, 4. And you can certainly reverse the order, doesn't matter. All right. Now let's simplify that. We're going to have a slope of 3 on the top and -6 on the bottom, and we can reduce that. So it's going to be a negative number, and it reduces to -1/2. So we can plug it back into the equation. Y equals -1/2 x plus b. Now we can take either one of these 2 points, the first one or the second one, and plug those x and y values in to figure out our b. All right, so let's use this one here. 3 is equal to -1/2 times 4 plus b. So I'm going to move over here so you can see 3 is equal to, okay, -1/2 times 4 gives us -2 plus b. And then I'll subtract, or actually I'll add to the opposite of this to both sides. And then this will go away and I'm left with a 5. So b, 3 plus 2 is 5. So b equals 5. And then the last thing to do is just plug in to the original. Y equals, our slope was -1/2. And then our b value was 5. Now if I wanted to double check to make sure I was right, I could take and plug in the other. So here I was using 4 and 3. I could use my other point, the -2 and the 6, to plug into here to see if I get a true statement. So let's just check to see if we're right. So I've got y, which is 6. That's equal to -1/2 times -2 plus 5. 6 is equal to -1/2 times -2 gives us a +1 plus 5, and 6 is equal to 6, so it's a good check. Therefore, I know this is the correct answer. All right, that's going to be a little help with number 2. For number 3, these problems are dealing with exponents. There's a good review of the laws of exponents in the YouTube channel, so make sure to check those out if you're not sure how to do those. For problem number 4, you're using the equal values method. Given the systems of equations, you're going to leave your answer as an xy coordinate, and then you always want to make sure you check your solution with the other equation. So here it's just setting the right sides of both of these equations equal to each other. All right, I'm going to do an example with elimination, all right, that is going to help you with these two. Sometimes the elimination is nice and easy where you've got opposites or the same stacked up over the top of each other, and there's no other things you need to do. Other times the problem is going to be a little more difficult, where you're going to have to manipulate one or both of your equations. So here's an example. 3x plus 2y is equal to 9, and you've got 2x plus 6y is equal to 6. So the x terms need to be in line with each other, the y terms need to be in line with each other, and the constants need to be in line with each other. So that's the case. But we don't have a situation where we have the same exact terms or the exact opposites, where we can just either add or subtract one equation from the other to create elimination. So what we have to do is manipulate them. We can either multiply something by to both of them to change it so we can create that situation, or in this case, it looks like that 2y and the 6y. I could easily change the 2y to 6y by multiplying by 3. So I'm going to take this and I'm going to multiply this top one by 3. And that's going to change it to 3 times 3x is going to give me 9x. 3 times 2y gives me plus 6y. And then 3 times 9 gives me equal to 27. So I changed the top one by multiplying every single term by 3. And then now, the bottom one, I'm just rewriting. And what I've done is I've created a situation where I've got the same exact terms here, 6y and 6y. So if they're the same or they're opposites of each other, then I can create elimination. So I'll draw a line underneath both of those. And I'm going to, in this case, I'm going to subtract. So I'm going to put a minus sign over here nice and big that I remember to subtract. So 9x minus 2x gives me 7x. 6y minus the 6y is going to create the elimination. That goes away. And then I'm going to have 27 minus 6, which gives me 21. And then I can divide by 7. So I'm left with x is equal to 3. All right, from there, I'm going to use one of the equations. I'm just going to take that x equals 3 and I'm going to plug into the first one. So 3 times 3 plus 2y is equal to 9. So 9 plus 2y is equal to 9. I'll subtract 9 from both sides. It turns out that 2y is equal to 0. And then I can just divide both sides by 2, so y equals 0. So I think my answer is 3, 0. Okay, x value of 3, y value of 0. I won't know for sure unless I do a check. So in the first example here, I used the first equation. Now I'm going to check my solution with the bottom equation, the second one. So I'll just basically plug in the answers I think I have for x and y into the other one and see if I get a true statement. So 2 times the 3 plus 6 times the 0 is equal to 6. 2 times 3 is 6. 6 times 0 gives me 0. So 6 does, in fact, equal 6. Therefore, I know this is the correct answer. So that's how you go about using elimination. You might have to multiply something by each of them to change both of them. But basically, you stack them on top of each other, and you either add or subtract to create the elimination. Once you find one answer, or one variable, it's not always going to be x. Maybe you eliminate the other ones and you end up finding what y is. Then you're going to plug into one equation to figure out what the other variable is. And then before you go thinking you're correct, make sure you plug into the other equation that you didn't use to make sure, using this check, to make sure you got the answer right. All right, hopefully that helps you with your homework. It'll be attached in the Google Classroom. You can either print it out and do the work right on that page, or you can do it on a separate piece of paper and then submit your image in the Google Classroom. Thanks for listening.